Good morning, all. And today we are going to discuss about the VI characteristics of diode. I think for the first two lectures we are discussed about the construction of diode and working principle of diode. And now we are going to discuss VI characteristics of diode. So previously we are discuss about construction and working. Just we have to recall all the points. As we are a DD based class, we have to recall the points. So anyone can say for the last class we are discussed about working principle of diode. So type of bias we are discussed. That is one is the forward bias and another one is the reverse bias. What is meant by bias? Yes, we are applying the external voltage through the battery, through the external source uh, to break down the region or break down the barrier. We can say it is the bias. Very good. So, shall we go to the class? Today we are going to discuss that is VI characteristics of diode. So, see the diagram. If you are going to the lab, we have to do or connecting the circuit for find out the VI characteristics as such in the diagram. That is here there is a battery and there is a variable rheostat. That variable rheostat is connected to the resistor. One end of resistor connected to the voltmeter and again ammeter also, and another end of ammeter connected to the anode, and the cathode is connected to the another end of voltmeter, and from the voltmeter we can connect it to the rheostat of one end, and another end, that is there are two ends are available, that is three terminals are available in the rheostat. There are two fixed ends and one is the variable end. So first we have to positive and negative are connected to the two fixed end and variable is connected to the one end of resistor. This is how we have to connect in the lab. So after that we are increasing the voltage, that is the bias voltage. We can say we are using in the lab 50 volt power supply, that is a voltage RPS regulated power supply, or 30 volt. So first you have to increase the voltage, and based on the rheostat, if you are increasing the current voltage, and voltage will be increased based on the voltage, there is a current will be increased when the voltage is applied more than the bias voltage, right? So more than the bias voltage if you are applying, the region will be breakdown. Already we have discussed in the last session. So VI characteristics after taking reading. So how can we taking reading for the forward bias? First we have to connect anode to um, that is one end of anode is connected to the voltmeter, and cathode is connected to the voltmeter according to this diagram, and the negative of the diode is connected to the ammeter positive, and ammeter negative will be connected to the resistor is connected to the fixed end of rheostat, and from this fixed end we can connect it to the negative of the voltmeter. Just we have to increasing the rheostat value. First we have to apply the negative, that is applied voltage, and if you are increasing the rheostat voltage according to that, it will be shows the value of ammeter and voltmeter. So first you have to take the values. For if you are for the reverse bias, we have to reverse the diode. That is first anode is connected to the ammeter positive, and cathode is connected to the rheostat. So after connecting the diode in the reverse bias, what will happen, that we have discussed in the last class, the depletion region will be larger. So more than the voltage we are applying, it is not sufficient to conduct the barrier from that is carriers from one region to another region. If more than that voltage we are applying, just maybe it is heated, and maybe it more than that it may be break down the diode also. So and if there is a minority carrier, there is a small amount of current will be flow through the meter, then the circuit, and it is not enough to break down the region. So that's why we can say in reverse bias the PN junction diode will not work. In forward bias, we know that if you are increasing the voltage more than the zero point 0.7 or zero point 0.3 based on the silicon or germanium, the breakover voltage more than the breakover voltage, that we can say the breakover voltage, and it break down the region, then the current will be increased according to that increase in the voltage. So first you have to note down the value of voltmeter and ammeter. Step by step we are increasing the gradually we have to increase the rheostat, according to that voltage and the current will be increased. So see the diagram of characteristics of forward bias. There is a x-axis, in x-axis we are considering the voltage, and y-axis we are considering the current in forward bias. So VF and IF. In a point 0, there is no voltage and there is no current if you are not applying the voltage. If you are applying the voltage up to zero point 0.6, see the diagram, there is a P. Here you have to mention more than the 0.6 voltage for silicon, and more than the 0.6 or 0.7 voltage will be, there is the linear increase in the voltage. If you are increasing the voltage, the current will be also increasing. So linearly it increase from the point P to Q. Increasing the voltage, according to that the similarly the voltage current also increasing. So up to 0 to P, there is a small amount of current will be flow, and break down the region will be more than the voltage we are applying. So that we call it as the forward bias. In reverse bias, uh, here the clearly in the diagram, forward bias, there is a points on voltage. After that, there is a linear increasing in the voltage and the current. And in this condition, the diode behaves as a closed switch and it allows the current to flow. That's why we are saying the application of diode is acting as a switch. In reverse bias, already I told you the large amount of wider width is increased in the depletion region. Why? Because positivity connected to that is P layer is connected to negative, and N layer is connected to positive. So based on this, the wider space is available in the region. If you are applying more than the voltage, it is not if sufficient to move the movement of charge carriers from one layer to another layer. So based on this, the small amount of current will be flow, and based on the minority carrier. So it is not sufficient to break down the region. So that's why you can say it is the VI characteristics is not works, that is not conducted in the reverse bias. And this is the data-based empathize, phase empathize, level signal control, and the pinpoint is leakage and heat issues. Like this, you have to empathize and define as the type of application rectification, PN diode rectification, Zener diode is voltage regulation, and LED is lighting, lighting and the indicator, and the Scotchy diode has high speed switching, and photodiode is sensor and communication. And real world application, we have to use rectifier, voltage multiplier, voltage over voltage limiter, clipper and clamper, reverse current protections, and digital logic gates, solar panel, and signals, communication signals. Also, we have to use PN junction in the real world application. And here I have mentioned a few diagrams, that is pictures, to show you to identify the applications where we have to use such as I told in the applications. So this is the reference, and thank you all. See you in the next topic. Thank you.